In this video, we will understand about what are the different fiber patch cord types, fiber connectivities. In fact, there is multi-mode fiber and single mode fiber, how the device to device connection via the single mode or multi-mode fiber is taking place, what are the different fiber optic types, what are their connectors. In fact, talking about fiber optic types, there are single mode, multi-mode, 1 gig, 10 gig, all those compendium of different combination in terms of the fiber connectivity. So everything would be understood here. Hence, here we start. The agenda is that firstly we'll have the discussion about the fiber cable types, then we'll move on to what are the fiber connector types, LC, SC, ST, all of them, and then what are the transceiver or the optic types, and lastly some connectivity types, how active and the passive infra are connected for end-to-end connectivity. With that, we'll start with first what are the fiber patch cable types, which are basically the patch cords of fiber. Now, the patch cords are fundamentally of two types. One is the single mode and other is the multi-mode type. Single mode are primarily for the longer distance, as it is written 10 kilometers, somewhere around that. And in addition to that, they also provide high bandwidth throughput of around 100 Gbps. Generally, the usage of the single mode is done in the WAN side of it. In LAN side also we can use it, but mostly it is from the WAN or the service provider connectivity end, or maybe when we are trying to connect one or the other building which is at a longer distance. So most of the time the single mode cable is colored yellow, as we can see in this picture, and the micron dimension is 9 micron. Now, what about the multi-mode? Multi-mode cable is primarily for the shorter distance of around 550 meters maximum. And here also we have two variants of multi-mode. One is the yellow or orange colored, as we can see in this picture, which provides 1 Gbps of throughput and primarily used in the LAN side because we are connecting two devices within that room or within that building. The distance is short, hence we can't use it for the longer distance or inter-building connectivity. Now for the 1 gig supporting maximum bandwidth multimode, the micron is the 62.5. However, for aqua colored multimode fiber, which can support up to 100 Gbps, the micron dimension is 50 micron. And now this is about the fiber patch cord types. Next, we'll move on to the fiber connector types, the fiber connectors. Here, we've seen multiple type of connectors being used for terminating the fiber onto the optics or onto the device. Now, LC, which is called the lucent connector, and it has replaced its predecessor SC in many of the cases. The best part about lucent connector is it is small in size, and it's about the latch feature is wonderful. Because of that, it has replaced many of its predecessors like SC, ST, and MPO in many of the cases. Now talking about SC, which is called the square connection or square connector or the subscriber connector. It is obviously taken over by LC, but in many cases for telecom applications also we are using SC presently also. Again, its setup is also push pull, and this is how its picture looks like. Next is the SC, the straight tip connector. It's again the predecessor of SC and LC type, and as we earlier said that for telecom and compasses it was widely used, but now the LC and SC have taken over. Lastly, we have MPO, which is multi-position connector. It is more of a push on and push off connector, and the best part is the density. the MPO connector provides. 24 fibers in one ferrule can take place. And that is why its density in the rack space is amazing, and that is where it is primarily used. Next, the transceiver types. Basically, the transceiver type, the SKU, have some features, and that is the feature we'll talk about, which help us to identify what is the transceiver or the optics type. Now, the standard rule, right hand thumb rule, is that for multi-mode short range, that is a shorter distance is required. That is why multi-mode cables or fiber optics are used inside the campus environment, within the building or within the room or the rack. However, single mode can travel up to longer distance. That is why on the WAN side, WAN connectivities, or inter-building when buildings are far away, long range fiber type or patch cords can be used there. Now, how to understand what the optics or the transceiver type says? There are some abbreviations which are written on the optics or the SFPs that will try to further decipher what they mean. Okay, whenever we have a multi-mode fiber, in that case, MM or MMD may be written, or SR or SX. SR is short range and SX is short wavelength. About single mode, SM or SMD is written, or else LR, long range, or long haul is written. When we talk about copper type of SFP or transceiver, T is the abbreviation which is embedded in that name, and it is easy to for us to understand. It is the copper SFP. Now, what is GLC? GLC primarily means gigabit interface converter, and it's a small form factor SFP. Just to reiterate, SFP means small form factor module, which is used in network equipment. Transceiver types. Let's see what the abbreviations that we discussed earlier mean here. So what we can see here is the first one, GLCT. So what does GLC means? It means SFP, as we understood in the last one. Everywhere we can see either GLC is written or else we have SFP written. So small form factor pluggable or the GLC, which again means the same thing. Next, okay, let's see which one is multi-mode or which one is the long haul or the single mode. So here what we can see is SX. SX means short wavelength. Here also SX means short wavelength, and SR means short range. So as quintessentially as we've seen, fundamentally short range is for the multi-mode fiber capability, while long range is for the long haul or the single mode. So SX, SX or SR, wherever we see, is short range, short wavelength for the multi-mode, while LH or LR is for long haul, that is single mode fiber. Now, again, another significant abbreviation in the naming of the abbreviation here is MM. MM means multi-mode. So that means this GLC or this SFP is going to be multi-mode capable only and not single mode. This one also is MM. And here it is T, which means copper. So this is what segregates what the single mode fiber will look like, that is SM or SMD, and multi-mode will be denoted by MM or MMD. These are the different transceiver types that we discussed about, and their related description is written here. Whatever abbreviations we understood, based upon that we can understand. For example, SFP 10G, 10 gig supportive. SR means short range, and this is short range, which is 300 meters only, that is supported by this. LR is long range, then obviously 10 kilometers supported by this SFP. Now, active and passive infrastructure connectivity. So we discussed about that this is the passive infrastructure and these are the optics. This is the network device, the switch. So optics, we talked about GLC, SX, MM. From here we can see GLC is for SFP, SX means short wavelength, MMD means multimode. So that means this optics would be inserted into this port of the switch and will communicate with the other SFP, which has to be of the same configuration and inserted here. However, what do you think should be the underlying cable in that case? Should that be single mode or multi-mode? Yes, you guessed it right. It has to be multi-mode supportive. Now the question part. Okay, what is the fiber type here? Fiber type. Okay, since this is aqua in color and also we can see 50, which means 50 micron, right? So that means aqua is for multi-mode, which can support higher throughput, and 50 micron is multi-mode. So fiber type is multi-mode here. What do you think is this connector type? As we can see, it is more of a push-pull type of connector and looks like the latest one. Hence it is, from the looks of it, LC connector type. Next is, how much bandwidth can this fiber provide? So we will say that the bandwidth can be up to 100 Gbps, but be mindful of the fact that additional information about this fiber patch cord is that it is a multi-mode patch cord with a 50 micron parameter. However, it cannot go beyond 550 meters. That is important consideration. Next question is this yellow colored fiber patch cord and what is the fiber type? So yellow represents single mode. And if we look here, we have a abbreviation which is given as 9. So 9 micron is obviously a significance of single mode fiber patch cord. Connector type, as we earlier saw, this connector type is basically LC. How much bandwidth it can support is 100 Gbps. And what about any additional information? That is obviously it can go up to 10 kilometers of distance because single mode is how it has been made that it can support a very long distance, and that is why it is used in telecom provider side, in WAN connectivity side by the ISP end. So third question is fiber type. Okay, what we can see here is 62.5 micron, and this micron represents multi-mode fiber. The connector type again is LC type here, and bandwidth supported by this is 1 gig because 62.5 micron fiber patch cord multi-mode can only support 1 G of bandwidth. Additional information is that it can go up to distance of max 550 meter and not more than that because it is not single mode and can only support shorter distance. So that takes us to the end of the slide, the video, and I hope you all like the fundamentals of passive networking, what are multi-mode fibers, single mode, how device to device connectivity happens, and about 1 gig, 10 gig connectivity, what are the limitations of optics or fiber patch cords and related things. Thank you very much.